Hello everyone, those who are live for the session, please say hi in the chat window so that we can start it. If you are available for the session, please say hi in the chat window so that we can start the session. Hi Mary and Pratibha, hi Jai. So maybe we can start today's session. Hello everyone. Great, so we can start, I guess. So in the previous sessions we have already discussed about what are NFAs, we have already discussed about what are DFAs, and we have seen what are the conversions of NFAs and DFAs. These things we have already covered, and we have also seen what is the difference between an NFA and what is the difference between an NFA and a DFA. These things already covered. So in this class we will be discussing about one more category of finite automatas, which is your Epsilon NFAs. So as I said, we have two categories of finite automatas. First is the finite automatas which is without output, and second is the finite automatas with output. So the finite automatas without output, there are three types, which is deterministic finite automata, non-deterministic finite automata, and third is your epsilon non-deterministic finite automata, or you can say epsilon NFA. So in this class we will be discussing about epsilon NFA, and all those people who are watching this session, please tell me you are comfortable with Hindi or you are comfortable with English. So I can speak in both the languages because most of the students, they say sir please speak in Hindi, some says please speak in English. So I'm comfortable with both the languages. So those who are present, please okay, so Pratibha is saying both. Great, so we can start, I guess. So in this session we are discussing about epsilon NFA. So we can say epsilon non-deterministic finite automata. As I told you, what exactly is the epsilon? Epsilon is a string of length 0. So there are few properties of epsilon that you should know. If you concatenate epsilon with any string, so for example if you have a string which is AB, correct? Now this string is having two symbols which is A and B, and the length of this string is 2. But if you concatenate epsilon anywhere in this string, for example if I can do epsilon dot AB, then it is equal to AB, or even if I do A dot epsilon dot B, or if I do A dot B dot epsilon, all these things are actually the same. You can even have more than one epsilons in a string, right? So epsilons, all these things are actually the same, so they are not different, representing anything else. So epsilon ka matlab kya? Epsilon means it is a string of length 0. Okay, so those who are saying video is not visible, please improve the resolution on your end. आप resolution को improve कीजिए, then you will be able to see the class. Okay, so epsilon here is a string of length 0. This is something we have already seen. Now what is the epsilon NFA? So you can define epsilon NFA like this. We have Q summation delta Q naught and F, and you already know what is Q. Q is the non-empty set of states. What is summation? Summation is non-empty set of input alphabet. What is delta? So in this case delta is different. When we say we have epsilon NFA, in case of epsilon NFA, delta is Q cross summation union epsilon takes us to 2 raised to power Q states. So this is the difference here. In case of delta function, we take a state. If you are at a state and you are looking at a symbol, you can make a transition, or if you are at a state just by looking at an epsilon symbol, you can also make a transition. और यहाँ पर जो 2 raised to power Q है, this 2 raised to power Q is representing the power set. This is representing the power set, right? Q naught is the same, Q naught is same, which is the initial state, and F is representing the set of final states. And as I told you that set of final states can also be empty. जो set of final states हैं वो empty हो सकती है. Okay. So let me see who all are online. We have Shraddha, Mary, Sonia, Priyanka, Mega Fashion or something. Okay, fine. Now let me give you some of the examples here. We can have an NFA like this, which is initial state is Q naught. Initially you are having any number of A and B. A. Then by looking at epsilon symbol, I can go to the state Q1, and here we have B as a self loop. And again by looking at epsilon symbol, I can go to the state Q2, and this is a final state, and here we can have C as a self loop. So basically it is an NFA, and this NFA is for the language which is A raised to power n, B raised to power m, C raised to power k, such that n, m, k is greater than or equal to 0. So यहाँ पर you can clearly see what is special here. The special is in a transition you can also give an epsilon symbol, and here the input symbols, which is a summation, is equal to A, B, C. There are 3 input symbols here, and the special thing is you can even make a transition by looking at an epsilon symbol. Okay. If I make one more example, so the next example is for the language which is A raised to power n, B raised to power m, B raised to power m, such that n, okay, I guess this portion is, but let me just rub it up again. So this next example is language is A raised to power n, B raised to power m, such that n, m is greater than or equal to 0. This is again one more example of a language. For this language you can make a DFA, for this language you can make an epsilon NFA, you can make an NFA, you can also make an epsilon NFA. Okay. So the epsilon NFA will look something like this, which is initial state is Q naught. Initially you can have any number of A's, but if you get a B, then you will go to the state Q1, and here you can get any number of B's. So here you can see we have an epsilon transition. Okay. तो यहाँ पर आपके पास जो है वो एक epsilon transition है. So I believe you are able to understand this one. But if you make a DFA for this, देखो ये जो है, this is representing an epsilon NFA for this. This is representing an epsilon NFA, correct? And you can also make a DFA for this language. We have already seen the DFA. तो इसका DFA कैसे होगा? How does the DFA look like? So DFA will look something like this, that you have an initial state which is Q naught, and you are going to make this initial state as a final state, because in this language even epsilon is present. Okay. In the beginning you can get any number of A's, but if you get one B, then you should always get a B, then you will go to the state Q1, and here you can have any number of B's. And here in this case, if you get a again, then you will go to the trap state which is Q2 maybe, and this Q2 is a trap state. You can have any combinations of A and B. So यहाँ पर again you can see we have given one transition for every symbol, that is for symbol A as well as for symbol B. Now this one is representing your DFA, which is for this language. तो आपके पास अब 3 कॉन्सेप्ट यहाँ पर हो गए हैं. So we have seen 3 concepts here. One concept is your DFA, but is deterministic finite automatas. Second concept is your NFAs, which is non-deterministic finite automatas. And third concept is your epsilon NFA, which is epsilon non-deterministic finite automatas. Okay, just have a look at it, note it down in your notebook, and if you have doubt, please ask. Otherwise I'll take more examples here. So done. Okay, great. So let me rub it up. So So let me take examples of an NFA and let me see how can you convert an NFA to a DFA. Epsilon NFA to an NFA or epsilon NFA to DFA. Okay. So your first example is for the language, which is a raised to power n, b raised to power m, c raised to power k, such that n, m, k is greater than or equal to 1. Is it visible to all of you? Is it visible? Good. So यहाँ पर we have created an epsilon NFA. This is the initial state, which is Q0. So initial state, if you can get n number of A's, by looking at epsilon symbol, you are going to the state Q1. You can get n number of B's. Again, by looking at epsilon symbol, you are going to the state Q2, and again you can have any number of C's. Okay. तो एप्सिलॉन का मतलब क्या है? हियर एप्सिलॉन मींस विदाउट लुकिंग एट एनी सिंबल यू कैन स्टिल मेक अ ट्रांजिशन. अगर आप कोई सिंबल नहीं देख रहे हैं, इवन इफ यू आर नॉट लुकिंग एट एनी सिंबल, स्टिल यू कैन मेक अ ट्रांजिशन हियर. दैट इज द मीनिंग ऑफ एप्सिलॉन. ओके. So before I convert this epsilon NFA to a NFA, or you can say epsilon NFA to an NFA, or you can say, and you can convert this NFA to a DFA. To convert this, we need to learn something called as epsilon closure. There's something called as epsilon closure. So first of all, let us try and find out what exactly is the epsilon closure. Epsilon closure होता क्या है, and we will try and identify that. तो सबसे पहला आपके पास आता है यहाँ पर epsilon closure. So epsilon closure means if you are at a particular state, if you are at a state particular, जैसे if I say if you are at a state Q0, now without looking at any symbol, that means without even by looking at a symbol of length 0, without looking at any symbol, what are the states you can go to? Okay. For example, currently if you are at a state Q0, and so without looking at any symbol, you can go to the state Q0 itself, or without just by looking at epsilon, you can also go to the state Q1. Again, just by looking at an epsilon, you can also go to the state which is Q2. That is your epsilon closure. So for that you should understand the property. If you have epsilon dot epsilon dot epsilon, that is equivalent to epsilon only, or epsilon dot epsilon is also equivalent to epsilon. Okay. तो you can easily compare this with an example of 1 in mathematics. जिस तरीके से आप करते हैं मैथमेटिक्स के अंदर, if you have 1 multiplied by 1 multiplied 1, that is equal to 1 only, right? So in the same way, in this case also, when you have an epsilon which is string of length 0, even if you concatenate any strings of length 0, right? So here this dot is representing the concatenation. If you concatenate any number of strings of length 0, still you will get a string of length 0 only. Okay. So when I'm trying to say that we are trying to find the epsilon closure, that means just by looking at a string of length 0, what are the states you can go to? आप string of length 0 को देखकर कौन कौन से state पर जा सकते हैं? That is your epsilon closure. Now please try and write in the chat window what is the epsilon closure of the state Q1. State Q1 का epsilon closure क्या रहेगा? Please write that in the chat window. So the epsilon closure of Q1 is going to be Q1 itself as well as Q2. So if you take epsilon closure of Q1, you can go to that state itself, or you can also go to Q2. In the same way, if you try to find the epsilon closure of Q2, that is going to be Q2 only. This is the epsilon closure of each of these symbols. I hope it is clear to all of you. आप सभी के साथ ये clear होगा. Let me take one more example here. So this is the second example, and the language and the DFA is something like this. You have a state which is okay. So you have a state which is Q0, initial state, and here you have a transition for B. Then by looking at an epsilon, you can go to the state Q1, and here we have a transition for A. By looking at an epsilon, you are going to the state Q2, and this is the final state. And in Q2, if you are looking at A, you can go to Q1, and in Q2, if you are looking at B, you can go to Q0. This is again an epsilon NFA, because here we have epsilon transitions. Now tell me, what is the epsilon closure of the state Q0? What is the epsilon closure of the state Q1? And what is the epsilon closure of the state Q2? Please write in the chat window what is the epsilon closure of all of these states. सभी से आंसर चाहिए, so please write in the chat window. Okay, good. So if I take the epsilon closure of Q0, that means you can go to the state Q0 itself, and from Q0 by looking at epsilon you can also go to the state Q1, and from Q1 by looking at epsilon you can also go to the state Q2. That is your epsilon closure for Q0. And if I take Q1, for Q1 the epsilon closure is going to be Q1 itself here, and you can also go to the state Q2. And if I take the epsilon closure of Q2, so there is going to be Q2 only. So in the this example and this example, the epsilon closures are same. Sometimes it can happen that epsilon closures are not same for some cases, but here in these two cases the epsilon closure is exactly the same. Okay, तो यहाँ पर आपका जो epsilon closure है वो same है. So what I'm going to do is, whenever I want to convert an epsilon NFA to NFA, I need these epsilon closures. So what I'll try to do here is, I'm trying to identify if I'm at a particular state. Now if I take an epsilon symbol, so what are the states where I can go to? I mean, if I have a string, like if you have a string of A, so this A can be written as epsilon dot A, it can also be written as A dot epsilon, it can also be written as epsilon dot A dot epsilon. Okay, I mean, for example, if you are at a state Q0, right? अगर आप Q0 state पर है, if you are at a state Q0, now by looking at a symbol A, you can go to Q0 itself, or you can also concatenate A with epsilon. So that means first of all you can see this epsilon symbol, and then you can see this A symbol, right? In the same way, you can embed or you can concatenate this string A with any number of epsilon symbols. You can even say we have epsilon dot A dot epsilon. This is exactly equal to A only. So what we will try to do is, for every state we will try to identify that if we give a symbol A on that state, if we give a symbol B on that state, if we give a symbol C on that state, now what are the states we can go to? Okay, and then we will make transitions for that. So those people who understand in Hindi, let me repeat the same sentence in Hindi. तो basically हमें करना ये है कि अगर आप किसी एक स्टेट पर है, जैसे कि अगर मैं Q1 स्टेट पर हूँ, तो Q1 स्टेट पर मैं ये देखने की कोशिश करूंगा कि अगर मैं Q1 स्टेट पर सिंबल A को देता हूं तो मैं किस किस स्टेट पर जा सकता हूं. लेकिन ट्रिक ये है कि जब भी आप उस सिंबल को देंगे, then you are going to assume that you can concatenate epsilon in the beginning, you can also concatenate epsilon on the end. So for every state I will try to identify what are the states where we can go to. Okay, so what I'm going to do is, I will take epsilon. Let us suppose if I'm talking about the state Q0. Now for that I'm going to identify, because we have three symbols, which is summation is equal to A comma B comma C, because we have three symbols. So for any state I'm going to see if we give a symbol A, so what are the states we can go to? If we give a symbol B, what are the states we can go to? If we go to the symbol C, what are the states we can go to? So for symbol A I'm going to give A epsilon dot A dot epsilon. For symbol B I'm going to give you epsilon dot B dot epsilon. For symbol C I'm going to give you epsilon dot C dot epsilon. Okay, so जैसे कि for example if we try to identify for symbol A, so if you are at a state Q0, so just by looking at epsilon symbol on state Q0, what are the states you can go to? That is the epsilon closure of Q0. So you can go to the state Q0, you can also go to the state Q1, you can also go to the state Q2. Okay, now if you are at state Q0 and you are giving a symbol A, then you are going to the state Q0 itself. If you are going to the state Q1, if you are at state Q1 and you are looking at a symbol A, अगर आप Q1 पर symbol A को देंगे, then you are not going anywhere, you are going to phi. And if you are at a state Q2 and you are giving a symbol A, then you are not going anywhere, you are going to phi. So again for this Q0, if you give a symbol epsilon, so we can go to Q0, Q1 as well as Q2. What it means is कि अगर आप Q0 स्टेट पर है और आपके पास इनपुट सिर्फ सिंबल A है, तो उस केस में आप इन तीनों स्टेट्स पर जा सकते हैं, because this symbol A can also be written as A dot epsilon or any way you like. So anyway you can write it this way. In the same way you will see if you are at a state Q0, and you will try to give a symbol B, so what are the states you can go to? तो आप किस किस स्टेट पर जा सकते हैं? So if you are at a state Q0, by looking at epsilon you can go to the state Q0, Q1 and Q2. And if you are at Q0, by looking at a symbol B, you are not going anywhere. If you are at state Q1, by looking at a symbol B, you are going to B itself, that is Q0 itself, Q1 itself, sorry. And if you are at state Q2, by looking at symbol B, you are not going anywhere. So here we got a state which is Q1. Again, if you take the epsilon closure of Q1, so that is going to be Q1 and Q2. I hope it is visible to all of you. Right? In the same way you will try to identify with the symbol C also. So it will be like this. This is epsilon, this is symbol C, and this is epsilon, and this is the state Q0. So if you are at state Q0, by looking at epsilon you can go to Q0 as well as Q1 as well as Q2. So this is the epsilon closure. And in Q0, if you are going to give a symbol C, you will go to phi. In Q1, if you will give a symbol C, you will go to phi. In Q2, if you are giving a symbol C, then you are going to Q2 itself. Okay. Again, at Q2, if you will give an epsilon, so the epsilon closure of Q2 is Q2 only. It means in Q0, if you give a symbol A, you can go to Q0, Q1, Q2. In Q0, if you give a symbol B, you can go to Q1 and Q2. In Q0, if you give a symbol C, then you can go to Q2. That means this diagram can be modified in this way, which is you have three states, which is Q0, Q1 and Q2. So in Q0, by looking at a symbol A, you can go to Q0 itself, Q1 also, as well as Q2 also. Now here in Q0, if you give a symbol B, you can go to Q1 and Q2. So in Q0, if you give a symbol B, you can go to Q1 as well as you can also go to Q2. Now in Q0, if you give a symbol C, you can only go to Q2. If you give a symbol C, you can only go to Q2. This means that this kind of diagram is possible. So again, you can minimize this diagram. So here what you can do is, instead of giving these three transitions, you can just give A, comma B, comma C. You can go to this state, and here instead of giving this transition, you can just say here A, comma B. Okay, so that means by looking at these symbols in Q0, if you look at symbol A, you can go to Q0, Q1 and Q2. By looking at a symbol B, you can only go to Q1, as well as for Q2. By looking at a symbol C, you can only go to Q2. Now for Q1 state, do the same. For Q1, I will do epsilon closure A, again epsilon closure. Then for again Q1, I will do epsilon closure B, and again epsilon closure. And then again for Q1, I will do epsilon closure C and again epsilon closure. So this way you can also identify कि अगर आप state Q1 पे है, if you are at state Q1, by looking at this symbol, what are the states you can go to. So for example, the epsilon closure of Q1 is Q1 and Q2. So this is Q1 as well as Q2. Again this is Q1 as well as Q2. Again this is Q1 as well as Q2. Okay. So if you give a symbol A to Q1, you are going nowhere. If you give a symbol A to Q2, again you are not going nowhere. So epsilon closure of phi is phi. In Q1, if you give a symbol B, you will go to Q1 itself. But if you give a symbol B on Q2, you are not going anywhere. So again the epsilon closure of Q1 is Q1 and Q2. And in Q1, if you give a symbol C, you are not going anywhere. But if in Q2, if you give a symbol C, you are going to Q2 itself, and the epsilon closure of Q2 is Q2. It means if you are at state Q1 and you are giving a symbol B, so by giving a symbol B, you can go to Q1 itself, as well as you can also go to Q2. By giving it symbol C, you can go to Q2 like this. Okay. Now in the same way, you will also find the same thing for C. Okay. So this is epsilon C, and this is again epsilon closure, and this is the state Q2. So epsilon closure of Q2 is Q2, and if you give a symbol A to Q2, so there is going to be phi. Again epsilon closure, symbol B, and epsilon closure. So epsilon closure of Q2 is Q2 only. If you are giving a symbol B, you are not going anywhere, so this is going to be phi. Again epsilon closure, symbol C, and epsilon closure. So in Q2, if you are giving epsilon closure, so it is going to be Q2, and again by looking at a symbol C, you will go to Q2 itself, and this is going to be again Q2. That means in Q2, by looking at a symbol C, you will go to Q2 only, and you are not going anywhere. So basically what we have done here is, if you look at it more clearly, what we have done is, we have a diagram which is representing epsilon NFA, and now we have converted this epsilon NFA to a diagram which is representing an NFA. Further, you can convert this NFA to a DFA, and then you can minimize the DFA. उसके बाद आप उस DFA को minimize कर सकते हैं. So if you look at more clearly what I have done, let me explain this whole procedure again. So what I am trying to say is, if I am standing at a particular state, for example, if I am standing at a state Q0, if I give a symbol A, then what are the states where I can go to? If I give a symbol B, what are the states where I can go to? If I give a symbol C, what are the states where I can go to? So if you are standing at a state Q0, by giving a symbol A, you can go to Q0 as well as Q1 as well as Q2. So for Q0, if I am giving a symbol B, you can go to Q1 as well as Q2. But if you give a symbol C, you can only go to Q2. Okay. So for every state, we have to find this type of transitions, and then by looking at it, you can convert this epsilon NFA to NFA. So are you able to understand this? क्या आप सभी को समझ में आया? Is there anyone who could not understand this? Okay, नहीं आया. So no problems. Let me give one more example. मैं एक बार फिर से समझाता हूँ जय आपको, then फिर आपको समझ में आएगा. Let me take one more example, then maybe you will be able to understand this. Okay. So let me take an easier example or a smaller example this time, so that you will be able to figure that out, what I'm trying to do here. Okay. So this time the example was bigger, but I'll take a smaller example. So let us suppose we have a language which is a raised to power n, b raised to power n, such that n is greater than n is greater than or n comma m is greater than or equal to 0. This is your example: a raised to power n, b raised to power m, such that n comma m is greater than or equal to 0. Okay. Now here I can make a DFA, and we have already done this. So how does this DFA look like? We have an initial state which is Q0, and it is also a final state. You can give n number of A's here. If you give a single B, so you will go to the state which is Q1. Again, it is also a final state. You can give n number of B's here, and again if you get a single A here, then you will go to the state Q2, which is basically a trap state, or you can say dead state. You can give any A or B here. So this is representing a DFA for this. I can also make an epsilon NFA for this, and making an epsilon NFA is much easier. It is very simple. आपके पास initially you can have n number of A's. By looking at an epsilon, you can go to the state Q1, which is getting n number of B's. That's it. तो ये जो आपके पास है this second diagram, I mean this much part only, because I have less space, so I'm writing like this, so this much part also only it is representing your epsilon NFA. Now what we are going to do is we are going to convert this epsilon NFA to NFA. So first of all, let us try to identify epsilon closure for the state Q0 as well as epsilon closure for the state Q1. अगर आप Q0 का epsilon closure लेंगे, so epsilon closure of Q0 is going to be Q0 itself as well as Q1, and epsilon closure of Q1 is going to be Q1 only. Okay. Now let us do the procedure, the entire procedure. So first of all, because here we have only two symbols, that is summation is equal to a comma b, we have only two symbols. So I'm going to do this procedure for two symbols only, that is epsilon a and epsilon for the state Q0, and then again I'm going to do the same procedure, that is epsilon b and epsilon for the state Q0. तो देख सकते हैं, for Q0 the epsilon closure is Q0 as well as Q1. For Q0 again it is Q0 as well as Q1. In Q0, if you are looking at a symbol A, you are going to Q0 itself. In Q1, if we are here in Q1, if you are looking at a symbol A, you are not going anywhere. And again the epsilon closure of Q0 is Q0 and Q1. And for Q0, if you are looking at a symbol B, अगर आप Q0 पर हैं और आप symbol B को देखते हैं, so you are not going anywhere. And in Q1, if you are looking at a symbol B, you are going to Q1 only. And again the epsilon closure of Q1 is Q1. Okay. Then do the same procedure for symbol B. So we have epsilon, symbol B and epsilon. So we have the state Q0. In Q0, if you give a symbol epsilon, you can go to Q0 as well as Q1. So this is basically for state Q1. So this is for the state Q1. So in Q1, if you're looking at epsilon, you can only go to Q1. And then by looking at a symbol A, in Q1 you are going to phi, and epsilon closure of phi is phi. And in Q1, again epsilon closure of Q1 is Q1. If you are looking at a symbol B in Q1, you are going to Q1 only, and epsilon closure is again Q1. What it means is, इसका मतलब क्या हुआ? It means if you make the straight transition table here, देखो आप थोड़ा ध्यान से देखो, I'm just trying to understand explain this in a different manner. So what does it mean? This is the symbol A and this is the symbol B, and for state Q0, by looking at a symbol A, we are going to Q0, comma Q1. You are going to these two states. If you are a state Q0, by looking at a symbol B, you are going to Q1. If you are at state Q1, by looking at a symbol A, you are going to phi. If you are at state Q1, by looking at a symbol B, you are going to Q1 only. Okay. So that means if you make a diagram for this, तो इसका diagram कैसा दिखेगा? The diagram will look something like this. We have two states, which is Q0 as well as Q1, and here Q1 was the final state and Q0 is the initial state. So in Q0, if I give A, I can go to Q0 as well as Q1. In Q0, if I give B, I'm going to Q1. And in Q1, if I give A, I'm not going anywhere. In Q1, if I give B, I'm going to Q1 only. Okay. So this is representing an NFA for this epsilon NFA. तो इस epsilon NFA को हमने इस तरीके से NFA में convert कर दिया. Okay. Now you can also convert this to a DFA. इसको आप एक DFA में convert कर सकते हैं. And how can you do it? Very simple procedure. We have done it yesterday also in the previous class. हम लोगों ने convert किया था कि आप किस तरीके से एक epsilon एक NFA को DFA में convert कर सकते हैं. So this is the transition table of an NFA. I'm going to convert it to a DFA. तो सबसे पहले in this case we have two states. So I'm going to combine both of these two states. So I'm going to make a new state here, which is Q0 Q1. And here we have Q1. And for Q0 Q1, so let me write Q0 Q1. So for this new state, which is Q0 Q1, I'm going to take a union of them. So union will be Q0 Q1 here, and here it will be Q1 only. And if I try to explain Q1, so in case of Q1, I'm going to write this entire row as it is. So it is phi and Q1. And because we have phi, so I'm going to change it to the dead state. Okay. So the diagram looks something like this, that we have a state which is Q0. We have a state which is Q0 Q1. We have a state which is Q1, and we have a state which is a dead state. So in Q0, if I give a symbol A, I'm going to Q0 Q1. In Q0, if I give a symbol B, I'm going to Q1. So in Q0 Q1, if I'm giving a symbol A, I'm going to Q0 Q1 only. So in Q0 Q1, if I'm giving a symbol B, I'm going to Q1. Here I'm going to Q1. And here in Q0 Q1, if I give a symbol A or B, I'm going to a dead state. तो यहाँ पर हम लोग एक dead state पर जा रहे हैं. We are going to a dead state in this case. Okay. Now here we are going to a dead state, and this is again a dead state. Now you can clearly see that in this case, in the previous case here, we were having Q1 as a final state. So here wherever we have Q1, I'm going to make it as a final state. So this is representing a final state, as well as this is also representing a final state. Okay, so this Q0 Q1 is a final state, as well as this Q1 is also representing a final state. Now you can clearly see this diagram is very close to this diagram. The only difference in those two diagrams is here you have initial state as a final state, okay, and here you are not making the initial state as a final state. So यहाँ पर जो initial state है, we are not making it as a final state. But what you can see here is that if you take this Q0, just by looking at the epsilon symbol, you can go to the state Q1, and Q1 is a final state. I mean, if you give any symbol, if you give a symbol A, if you give a symbol B, you are going to a state which is a final state. So maybe you can also convert this state as a final state. Okay, so you can easily convert, you can easily do it, you can easily convert the state as a final state, but then what you have to do is you have to minimize this DFA. After this you have to minimize this DFA. After minimizing this DFA, you will get a diagram which is as equal to this. So you will get a diagram which is equal to this diagram. Okay, is it clear to all of you? So this is a diagram which is a DFA, which is presenting this NFA. You can make this Q0 state as a final state, because here in the original case in Q0, just by looking at epsilon, you can also go to a final state, right? So that is why you can also make this state as a final state यहाँ पर. Clear? So this is the entire procedure. Whenever you have an epsilon NFA, you can convert to this epsilon NFA to NFA, and further you can convert an NFA to DFA, and further you can minimize this DFA to get a diagram something like this. Doubts? Is there any doubt here? Is it clear? Good. I hope I made this point clear till now. Let me give you some more examples to convert an epsilon NFA to NFA. I'll explain one more example only, and then you can do rest of the examples by yourself. I also sent you some of the examples in the Telegram group, so you can see them also. So we have the following examples. The first example is like this, which is initial state is Q0. By giving epsilon, you are going to Q1. By giving epsilon, you are going to Q2, 0, 1. Here we have Q3, and by giving 1, you are going to a state which is Q4. Okay, so this is the second example, which is something like this, that you have initial state which is P, you are getting a transition for A. By giving the symbol B, you are going to the state Q. Here we have again a transition for A. This is an epsilon transition. This is the state R, and this is the transition for symbol C, and this is B, and this is again epsilon transition, and here we have a transition for A. And then we have this third example. We have this state which is Q0. We are giving a symbol B. This is epsilon, this is Q1, we are giving a symbol A. This is epsilon, we are going to Q2. This is the final state. Here we have a transition for A, and here we have a transition for B. These are the 3 examples you can practice. Please note down these examples in your notebook. I have also sent you these examples in the Telegram group. Okay, I can also write one more example for your practice purpose only, but still I am not going to solve this here. This is the state Q0. By looking at epsilon, I am going to the state Q1. By looking at a symbol 0 or 1, I am going to Q1 only. By looking at epsilon, I am going to the state Q2. After giving 0, I am going to Q3. By giving 1, I am going to Q4. By giving 0, I am going to Q5, and this is 1. By giving again epsilon, I am going to Q6. Here we have a transition for 0 and 1. By giving epsilon, I am going to Q7. So maybe this example number 4 will be very lengthy. So obviously I am not going to solve this example number 4. So out of all these 4 examples, I will only explain you this example number 1 in the session, in this class, and all the 3 examples here, rest of the 3 examples you can use for your own practice. तो अपने practice purpose के लिए जो rest जो तीनों examples है आप यहाँ पर use कर सकते हैं. Okay? So let me wrap it up. I hope that you have noted it down in your notebooks. So let me take the first example here. So in the first example you have 2 input symbols, which is 0 and 1. Okay. Now first of all, let us find epsilon closure of each of these states. We have to find epsilon closure of the state Q0, again epsilon closure of the state Q1, again epsilon closure of the state Q2, epsilon closure of the state Q3, again epsilon closure of the state Q4. Okay. For Q0, if you are looking at the epsilon symbol, you can go to Q0, as well as by looking at epsilon you can go to Q1, you can also go to Q2. Okay. By looking at epsilon symbol at Q1 you are not going anywhere. By looking at epsilon symbol at Q2 you are not going anywhere. So epsilon closure of Q0 is going to be Q0, Q1 and Q2. Then epsilon closure of Q1 is going to be Q1 only, because there is no epsilon transitions here. For epsilon closure of Q2 it is Q2 only. For epsilon closure of Q3, because we do not have any transition here, so it is Q3 only, and epsilon closure of Q4 is going to be Q4 only. Okay, so here you can clearly see what are the epsilon transitions in this diagram. So यहाँ पर आपके पास we have only 2 epsilon transitions, which is from Q0 to Q1 as well as from Q0 to Q2. We have only these epsilon transitions. Now what I want to do is I want to identify how can you convert this epsilon NFA to NFA. So first we will start with the state which is Q0. Okay, so I'm going to see if I give a symbol 0 to Q0, what are the states where I can go to, and then I'm going to see if I give a symbol 1 to Q0, what are the states I can go to. So for Q0 we will start with giving epsilon closure of Q0. So it is going to be Q0, Q1 and Q2. So again here also Q0, Q1 and Q2. उसके बाद if you give 0 to Q0 के अंदर अगर आप 0 देंगे you are not going anywhere. If you give 0 to Q1 you are going to Q3. If you give 0 to Q2 you are not going anywhere. For Q3 the epsilon closure of Q3 is going to be Q3 only. That means in Q0 if you give a symbol 0 you will reach Q3. अगर Q0 के अंदर आप symbol 0 देंगे तो आप Q3 के पास पहुंचेंगे. In the same way, for Q0 if you give a symbol 1 you are not going anywhere. For Q1 if you give a symbol 1 you are not going anywhere. For Q2 if you give a symbol 1 you are going to Q3. So again the epsilon closure of Q3 is Q3 only. That means अगर Q0 को अगर हम सिंबल 1 देते हैं, if we give a symbol 1 to Q0, so we will reach Q3. Is it clear? आप सभी के साथ ये क्लियर है? Any doubts till now? Now here again we have to check for the state Q1 also. For state Q1 I'll take epsilon closure. For symbol 0 again epsilon closure. We'll take epsilon closure. For symbol 1 we'll take epsilon closure, and so on, right? So this is for the state Q1. So epsilon closure of Q1 is Q1, epsilon closure of Q1 is Q1. So if you give a symbol 0 to Q1, you'll go to Q1, and epsilon closure of Q1 is Q1 only. But if you give a symbol 1 to Q1, you'll go to Q, you are going to phi, because there is no transition for 1, and again the epsilon closure will be phi. Okay, now you can do the same for Q2, and you will find if you give 0 to Q2 you are going to phi, if you give 1 to Q2 you are going to Q3. So these are things you can make for them, but because I have practice, so I can directly make the table, but let me just do one more for you. So let me do Q3. Okay, so this is epsilon closure 0, epsilon closure, and this is the state Q3. For Q3 the epsilon closure of Q3 is Q3 only. If you give symbol 0 to Q3 you are not going anywhere, that is phi, and again the epsilon closure will be phi. If you give a symbol 1 to Q3, that means you are going to the state Q4, then epsilon closure of Q4 is Q4 only. Okay, so this way you can create this kind of table for each of these states. You can create this table for Q0, you can create this table for Q1, you can create this table for Q2, you can create this table for Q3, you can create this table for Q4. So for every state we can make these kind of tables. Now what I'm doing is I'm not really making all these tables, because with enough practice you do not really have to make these tables. अगर आपको practice होगी तो उसके बाद आपको tables बनाने की ज़रूरत नहीं पड़ेगी. I have practice, so I can directly make the table even without making these tables. So how can I directly do it? So this is symbol 0 and 1, and this is the state Q0. Okay, so in state Q0 if I give a symbol 0 I can go to Q3, right? So I can go to Q3. In state Q0 if I give a symbol 1 I can go to again Q3. So how can you directly find it out? If I give a symbol 0, so epsilon closure of Q0 is Q0 only, and Q1 as well as Q2, right? So if I give a symbol 0 on Q1, you are not going you are going to Q3. If I give a symbol 0 on Q1, you are not going anywhere, right? In the same way, if you do for Q1, if you give a symbol 0, you are going to Q1 only. So you are going to Q3. Symbol 0, Q1, this is Q3, and this is going to be Q3 again. So I've done mistake here. So this is going to be Q3 for Q1. If I give a symbol 1 to Q1, it is not going anywhere. For Q2, अगर आप Q2 की बात करते हैं, if you are giving a symbol 0 to Q2, you are not going anywhere. If you give a symbol 1 to Q2, you are going to Q3. Then we have a state Q3. For Q3, if you are giving symbol 0, you are not going anywhere. But to Q3, if you give a symbol 1, you are going to Q4. Is it clear? इतना आप सभी के साथ clear है? Now, I've got this table, and this is your state transition table for a NFA. So you get an NFA here, and by looking at the state transition table, I can convert this NFA to a DFA. इस NFA को हम लोग DFA में convert कर सकते हैं. So here what was the final state? Q4 was the final state. So I'm going to make this state Q4, okay, and I'm going to make it as a final state. Now the problem is, how can I say that I can make the state Q0 as final? हम लोग यहाँ पर Q0 का final state क्यों नहीं बना रहे? Because if you take the epsilon closure of Q0 here, then all the states which is we are getting here, they are not final states, right? अगर आप Q0 के अंदर epsilon closure देते हैं तो आप final state पर नहीं पहुँच रहे. So if you take Q0 epsilon closure with 0, so you're not going, any of these states is not a final state. If you take Q0 epsilon closure with 1, any of these states is not a final state. So that is why I cannot make Q0 as a final state. So this is something that I got, which is NFA, and you can convert this NFA to DFA. Is it clear to all of you? क्या आप सभी के साथ ये clear है? Any doubts so far? क्या अब तक कोई डाउट है आप लोगों को? ओके, सो नो डाउट सो फार. सो आई बिलीव यू ऑल ऑफ यू अंडरस्टूड दिस वन. ठीक है, तो हम लोगों ने अब तक किया है व्हाट इज NFA and what is an Epsilon NFA. Now what you can do is you can take a break and you can try and solve the problems that I sent you. जो problems मैंने आपको send की थी वो आप solve कर सकते हैं. So in this session हमें सिर्फ Epsilon closure को ही समझना था and we have done it quite easily और काफ़ी जल्दी हम लोगों ने कर लिया. This was only a 40-minute session. So in this session we have already done Epsilon closure. Now what we will do is we will start the next session in 15 minutes. सो प्लीज़ स्टे ट्यून टू द चैनल. तो आप सभी को करना ये है कि अगले सेशन को ज्वाइन करना है. सो इन द नेक्स्ट सेशन वी विल बी कवरिंग अबाउट योर मिले मशीन एज वेल एज मुरे मशीन एंड देन वी विल बी कवरिंग द कन्वर्जन ऑफ मिले टू मुरे. सो इन Epsilon NFA it was not such a difficult task, it was easy, but the thing is the procedure becomes very lengthy when you have lot of epsilons. तो प्रोसीजर जो है वो काफ़ी लेंदी हो जाता है if you have more number of states, but again this task is very easy and it is not at all difficult. In the next session, we will be looking at what is a Mealy machine and a Murray machine and how can you convert a Mealy machine to a Murray machine and how can you convert a Murray machine to Mealy machine. And you have already seen this Mealy and Murray machine in your finite state machines in your digital logic. In digital logic, you have already seen these Mealy and Murray machine when we were studying counters. तो वहाँ पर हम already देख चुके हैं, but still we will be looking at Mealy and Murray machine here. In the next session, we will start the next session in 15 minutes. So all of you please be ready for the next session in 15 minutes. You'll get the notification from the channel and then we will continue. Okay. So I'm finishing the session here right now and we'll start at the next session now. I hope that you enjoyed this session. Bye bye.